once again. Activity number 4 is entitled Measuring Volume. We are done with the mass and we only have analytical balance for our mass determination. This time for measuring volume, marami tayong pwedeng gamitin for the measurement. So we have here units of concentration first. Either we use liter, which is also equivalent to 1 cubic decimeter. But most of the time, ang ginagamit talaga natin, milliliter. That's 1,000 of a liter. So do not forget our conversion factor. 1 liter is equivalent to 1,000 ml. Now, for the laboratory equipment that we may use in measuring the volume, we have the first one, the pipette. Do not forget that the pipette will help us measure exact and accurate volume of liquid and transfer it from one container to another. So most of the time, pipettes are used in the transfer of, again, the liquid sample from one container to another. And then the second equipment that we may use is the burette. So the burette is a long tube. I hope by now you are very familiar sa appearance ng burette natin. It's a long tube with graduation, just like the pipette. Meron din siyang graduation. And most of the time, we use the burette in titration processes. If we want to know the concentration of our liquid sample, then we do titration, and in measuring the titrant that is used for the reaction, we use the burette. And then for volumetric flask naman, it's a long neck flask with only one graduation. So isang graduation, isang linya lang talaga yan siya, unlike the burette na maraming linya for the measurement. Si volumetric flask, if it is for 1,000 ml, isang graduation lang talaga yon, and then that is for 1,000 ml only. But we have a lot of volumetric flask in the laboratory with different calibrations, different graduations. Meron tayong para sa 100 ml, 50 ml, and so on. Now, when is the time we use the volumetric flask? We use this one if we are going to make our own solution. Okay? So just like what we have computed sa lecture, like you will be asked to prepare a certain concentration of sodium hydroxide with a certain volume also. So dito natin siya i-prepare sa volumetric flask. Okay? Now let's start with the types of pipette. Please be familiar with this. We have a lot of pipette class. We have the volumetric more, and then we have two types of serological pipette, and then we have the Austral fallen, and two types naman of the Lambda Pipette, and the last one, the Eppendorf. So most of them are used to deliver. So, di ba kasi the purpose of the pipette talaga is to transfer liquid samples from one container to another. So, again, most of the time, they are used for to deliver. Well, we have one type of Lambda pipette that is used to contain certain volume of liquid. Now, for the function, depende kasi sa calibration niya. Sa volumetric pipette kasi, fixed volume kasi kagaya sila ng ating volumetric flask na isa lang ang graduation. Kaya this one is used to deliver fixed volume. The Austral fallen also, and the two types of the Lambda, and we have also Eppendorf, pwedeng fixed volume if they have one graduation only. But the rest, pag sinabi dyan, delivery of variable volumes, ito yung pipette natin, class, na kagaya ng ating burette na maraming linya, maraming graduation. So we can deliver variable volume of liquid, transfer it from one container to another. And pipettes also vary in size. When you say size, it refers to their capacity in ml. Kung gaano karaming liquid yung kaya nilang i-accommodate para ma-transfer from one container to another. So the largest pipette that we have is the volumetric pipette. It can accommodate up to 200 ml volume of liquid. So the rest, medyo maliliit na sila na mga pipette. Meron ng, especially the Eppendorf and the Lambda, they can actually measure up to microliter. So masyadong maliit na yun na volume. Pero nevertheless, kaya nila yun i-accommodate. Ganun kaliit na volume. Now, sa type of drainage naman, ito yung paano ba natin, di ba, magta-transfer tayo ng liquid from one container to another. Pag sinabing free lang siya, like the volumetric, we just let it flow. As we transfer it to another container, ipa-flow lang natin yung liquid. Pero yung kagaya ng more hanggang calibration line, meaning may maiiwan sa loob na pipette ng pipette na liquid. And we don't blow that out. Kung tumigil na siya sa pag-flow, yun na yun. Hindi mo na kailangan ipilit na i-blow out talaga lahat. Unless na lang yung isang serological pipette natin na blow out the last drop. Kailangan mo talagang ubusin ang laman niya. Pero pag sinabing calibration line lang siya, hanggang calibration line lang siya, if this is the pipette like this one, sa more pipette, hanggang dito lang yung liquid sa 10. Merong dito sa space na ito, let me write on the screen, merong maiiwan dito na liquid. So hindi mo siya kailangan i-blow out kasi ganun talaga yung kanyang calibration. Okay? Kung isasama mo itong naiwan dito, hindi na siya exact volume of the liquid. So you have to know your pipette also, whether that is a blown out pipette or to calibration line. Okay, meron ding kailangan mo siyang i-wash out just like the Lambda na nagko-contain ng fixed volume. Meron ding type of pipette na ito na kailangan mo siya i-wash out ng solvent, suitable solvent, and then ma-wash out lahat ng laman ng pipette. So you have to be familiar. Kung may binigay sa inyo na pipette, may gagamitin kang pipette, you have to be familiar whether that delivers exact or variable volume and at the same time that type of drainage wherein you are going to blow out or okay lang ba na may maiwan sa loob. So ito yung mukha class ng volumetric pipette and kagaya ng nakalagay sa table, this will deliver fixed volume of liquid. So kagaya nitong nasa gitna, this is for 100 ml. Meron niya siyang linya dito, isa lang ang linya niya and that is for the measurement of the 100 ml. Okay, wait lang ha, let me just fix my screen. Ayun. Wait. Wait. Ano mo? Okay. So I hope you can see my screen now. Again, this one is the so-called volumetric pipette. Do not forget, class, na this is used to deliver fixed volume. Isang graduation lang kasi siya. Okay? Next, we have here the more pipette. So ito naman delivers variable volume of our liquid. Kung sinabing variable, kung gusto mo 5 ml lang, 5 ml lang yung i-deliver mo. You can see it naman sa graduation niya na kagaya sa Burette, maraming linya. So hindi talaga necessary na 10 ml lang talaga, just like with the volumetric pipette a while ago. Okay, now this one is the so-called serological pipette. It's almost similar to that of the more pipette. This can also deliver variable volumes of liquid. Okay, pero I think when we go back to our slide, serological pipette kasi has two types. Meron tayong blown out na serological pipette na you really have to blow out everything. Kailangan walang maiwan na laman. Unlike sa more pipette na ito na mostly ginagamit natin sa lab, titigil talaga yan siya ang pag-flow hanggang dito sa last ng linya. And you don't need to blow out all those kasi mag-vary na ang kanyang measurement. Ito mostly sa serological pipette natin, blown out pipette talaga. And then this one is the so-called Austral pipette. It's a small one. And ginagamit ito, take note, kailan ginagamit sa Austral ginagamit ito for viscous fluids. Yung malapot na mga fluids, kung kailangan natin silang i-measure and transfer it from one container to another, it's the time we use the Austral. And this is also used for blood. Actually, other name for Austral pipette is blood pipette. Okay? So kayo mga medtech, ito yung mostly ginagamit natin pag nagde-deliver kayo ng blood. Kung gusto natin siyang i-transfer from one container to another. And then this one is the Lambda Pipette. This is also a small type of pipette. Therefore, ginagamit natin siya when we want to measure small amount of liquid only. So actually, it can measure up to 1 microliter. So ganun ka-konti yung pwede niyang i-accommodate na liquid. Pero pag mga microliter na, mostly ang ginagamit talaga natin si Eppendorf. Or this is what we call the micro pipette. So this is very useful in the laboratory, especially during laboratory testings. We don't actually use that much of the chemical substances or even the blood or yung pagpapainom ng gamot like sa mga animals natin sa laboratory. Hindi talaga siya necessary na masyadong marami. Most of the time, microliter lang. Kaya pinaka-ginagamit talaga si Eppendorf or si micro pipette. Okay, so let's get to know them. Again, this is what you call the Moore pipette. You can identify them sa kanilang calibration. And then masyadong malaki yung space here, hindi kasi siya blown out pipette. Ito kapag meron siyang bulb and isang calibration lang, this is what you call the volumetric pipette. And then ito sa gitna, this is called your serological pipette. It's almost similar to that of the Moore pipette, pero most of the time this is a blown out pipette. So you really have to blow out everything. And then this is the blood pipette, the Austral. The Austral pipette ito. This is used to deliver viscous fluids and also the blood. And then again, this is called the Eppendorf pipette or your micro pipette. And then lastly, ito yung Lambda Pipette na just like the Eppendorf, this can also deliver small volumes of liquid up to 1 microliter. I hope you are familiar now with the different types of our pipette. When we will have our face-to-face class, let's use them in measuring our volumes of liquids. Now, in cleaning our pipette, I hope nanood kayo sa video kanina. But anyway, I have provided also a link of the videos for cleaning the pipette since we cannot really do this sa atong mga balay kaya wala man tayo pipette din may pipette din ha. So video muna tayo ngayon. Now, always remember, how do you know that the pipette is dirty? Lagyan mo siya ng water. And then pag ang water class nag-form ng films inside, just like the video kanina, it means your pipette is dirty. So you have to rinse it hanggang na hindi na mag-break yung films ng water inside. So you can again use distilled water in cleaning the pipette. You can roll the pipette so that all the walls inside will be thoroughly clean. Okay, so actually we don't really use detergent in cleaning our pipette. Most of the time, it's just distilled water. And then after thoroughly cleaning it with distilled water, yung wala ng breaks, pwede na natin siyang lagyan ng solution na i-measure natin, pero ipara-run through lang natin so that all the walls inside will be coated also. So before talaga tayo mag-measure. Okay? And then in measuring an aliquot, class, you have to connect a rubber bulb sa taas ng ating pipette to draw water or to draw the liquid para mapunta siya sa loob. Okay? So, kailangan ang rubber bulb niyan. And kailangan mo munang i-wet ng liquid to be measured ang all the interior surface of the liquid at least twice. So yung purpose naman yan is to make sure that the inside is made up of the liquid to be measured, wala nang ibang contamination. Okay? And wala nang tubig na naiwan doon that can dilute our sample. Okay? So, just like the other, like sa graduated cylinder, when we measure class volume of liquid using a pipette, we also follow lower meniscus kapag clear solution siya. So since mag-curve yung liquid inside, lower meniscus tayo mag-read again para sa clear. Pero kung turbid ang solution mo, higher meniscus tayo. Okay? Now aside from the pipette, we also have the burette. So hindi ko na ipapakita yung video kasi pinakita naman na ito ng reporters just a while ago. Now in cleaning, so just like the burette, the pipette class, if there are film breaks of water inside the burette, that signifies that the burette is dirty. Kailangan natin siyang i-clean. We can rinse the burette with a distilled water, but kung twice na tayong rinse ng distilled water, hindi pa rin nawawala yung film breaks inside, that's the time we apply warm soapy water. So hindi yung naggabula-bula siya na na sabon, warm na soapy water lang, ilalagay natin inside and then we will rotate the burette so that all the interior surface will be cleaned. Okay, and then after having the distilled the warm soapy water, i-rinse na naman natin siya ulit ng distilled water. Pag hindi na kaya, we use the brush ha. Meron tayong tinatawag na burette brush. It looks like the test tube brush na meron tayo pero mahaba lang siya since mahaba yung burette natin. Now in filling, sa taas tayo magsisimula in filling the burette. We can use the funnel para malagay natin yung liquid natin inside. Pero yung burette natin, marami siyang linya class. Okay? Yung purpose ng rinsing is the same with that of the pipette. Kailangan after the distilled water, lagyan din natin ng liquid na sample natin inside and then i-drain just to make sure na nag-acclimatize na yung natin, yung burette natin, hindi na siya magkakaroon ng water pa that will dilute our solution. Okay? So parehas ba tayo ng sagot dito, reporters and other students? Ano ba ang sagot niyo dito? 17 point something? 17.2? Nag-start kaya sa 0.1. Actually, yung mga burette talaga, mag-start dapat sila sa 0.1. Pero yung nilagay namin dito, nag-start talaga siya sa 0. Just like this one, kasi the lower meniscus really sits on the 0 mark. And then the final reading here sits on 17.3 ba yan? 17.2. Hindi ko kasi hindi ko siya maklaro. 17 yan, 0.1. This should be 17.2. Let's just correct this. 17, no. Kasi itong mataas na linya here, dito sa gitna ng 17 and 18, that is supposedly 17.5. So the line after is 17.4, and then the lower meniscus sits on 17.3. So that is 17.3 for the final reading. Now, if the initial volume is 0, then we have 17.3. Okay? So yun yung nagamit. This is actually used during titration. So pag titrate, nagbaba yung volume of liquid. So pagbaba niyan, yan yung measurement ng nagamit. So from 0, nakagamit tayo ng 17.3. Okay, so variable volume pa rin ng liquid yung ating mini-measure using the burette. Pero again, mostly ginagamit ito for titration. And then kung gagawa tayo ng solution, ito yung ang gagamitan natin, volumetric flask. So isang graduation lang din yan siya. The graduation is found on the neck. But meron tayong available in different sizes depende on the volume of the solution that we are going to make. Kung 1,000, syempre yung itong nasa gitna. Ito, malaki na ito masyado. 2,000 ml, 2 liters talaga ng solution. Okay, so we also need to calibrate our volumetric pipette wherein i-measure natin kung tama ba yung kanyang measurement talaga. Though isa lang yung kanyang graduation mark, pero we need to still calibrate our volumetric, this is not volumetric pipette, it's the volumetric flask. Let me recheck that later. Kasi yung volume ng liquid, just like the mass, nagbabago yan siya depende on the temperature. Di ba when we learned about measuring mass using analytical balance, nakalagay doon, we have to acclimatize our sample first. If it's coming from heating or boiling, we have to lower the temperature first before measuring the mass kasi the mass will vary. Ito din, sa volumetric flask, nagva-vary din class ang kanyang measurement sa volume depending on the temperature. So we also have to correct the measurement here. So meron tayong table. I'm not asking you to memorize this. Kay murag daghan jud ni siya kaayo. Gagamitin lang natin itong table to correct the volume being delivered by our equipment. So meron tayong formula dito, class. Volume delivered is equal to the weight of the water times the volume at temperature. So this is used for both pipette and burette. In this example, you have here a 25 ml pipette. Nilagyan natin siya ng tubig. Nag-transfer tayo. When we measure, class, the 25 ml na na-deliver niya, ni-measure natin yung grams, 24.976 grams of water lang yun siya at 25 degrees Celsius. Diba sa lecture, nagsabi ako na 1 ml of pure water weighs 1 gram. Equivalent dapat sila, pero nung ginamit yung pipette, nag-25 ml na yung volume, pero yung kanyang weight 24.976 grams. That is for 25 degrees Celsius. So i-correct natin yung volume na na-deliver. Okay? Based on the temperature. Ika-calculate natin yung volume na na-deliver ng ating pipette both at 25 degrees Celsius and 20 degrees Celsius. So ito lang yung formula na gagamitin. At 25 degrees Celsius, again, volume delivered is equal to the weight of the water. Remember, yung pipette ang na-deliver niya is 24.976 grams. Tapos, i-multiply lang natin siya sa volume at temperature. Unahin natin yung 25 degrees Celsius. Saan natin makukuha itong value na ito? Doon sa table. Balikan natin si table. Hanapin natin, class. This is for, wait lang ha. Ayan. Ayan, this is for temperature which is 25 degrees Celsius. Ito yung 25 dito. At 25 degrees Celsius daw, ito daw yung madi-deliver ni pipette na volume. Okay? Ang 1 gram daw na tubig will be 1.0040 ml at 25 degrees Celsius. So if we are going to correct the measurement, kung nakikita nyo class on the screen, yung 24.976 minultiply siya sa 1.0040 ml per grams. So makancel itong grams. Ito yung correct volume talaga na na-deliver ni pipette at 25 degrees Celsius. So again, nag-vary yung volume kapag nag-iiba yung temperature. Kaya kailangan natin siya i-correct. Okay? Now, paano kung 20 degrees Celsius? Kasi most of our pipette are calibrated at 20 degrees Celsius. So, ganun pa rin. The same formula, yung weight of the water, i-multiply natin siya sa volume at temperature. Balikan nyo lang itong table na ito. Hanapin nyo class. Wait, let me delete the writings on the screen. Hanapin natin yung 20 degrees Celsius. So supposedly kasi, nag-measure tayo at 25 degrees Celsius. Ayan, kaya ito yung first one na ginamit natin. Pero the corrected temperature is 20. So dito mo siya titingnan. Ito lang yung volume na madideliver ng pipette kung i-calibrate natin siya at 20 degrees Celsius. Kaya, yung sa second computation, minultiply siya sa 1.0037. Ito lang din yung totoong volume na na-deliver niya at 20 degrees Celsius. Again, nagva-vary just like the weight. The volume also varies depending on the temperature of the liquid being measured. So we need to correct it using the table. So, supposedly talaga, di ba, 25 ml yung i-deliver niya. Pero nung chinek natin, ito lang yung weight ng 25 ml na water. So, kailangan natin siyang i-correct. So, kung 25 degrees Celsius, ang totoong volume na na-deliver niya is actually sobra 25.08. Pero at 20 degrees Celsius, mas tataas pa yan. That's 27.07. Be familiar with the formula, but you don't need to memorize the table. If we are going to include this one in our quiz and our exam, I will give you the table, or you are allowed to look at the table for the correction. And lastly, for calibrating a volumetric flask, we just have to clean our flask and dry it to the nearest milligram, and then lalagyan lang natin siya ng water and i-weigh. Ganun pa rin. Lagyan natin ng tubig yung volumetric flask. Example, 100 ml. Yun siya. Tapos pag na-fill na siya sa 100 ml, i-weigh natin yung water. And then i-check natin ang temperature. And then we will be using the same formula in correcting the volume being delivered by the volumetric flask. Ganun yung pag check whether the equipment is properly functioning or not. I-measure muna natin ang volume, tapos i-weigh natin yung liquid. Tapos using the table, we are going to correct the volume. Kasi most of our flask and our equipment are calibrated talaga at 20 degrees Celsius. Okay? Questions so far about activity number 4? Do you have clarifications? Wala. So we are going to